Hello everyone! One of my subscribers sent me a repaired LED flashlight. The problem is, the device won't turn on. According to the owner, the problem is with the power button. We tried disassembling the flashlight ourselves to fix the problem, but it didn't work. We then decided to send the equipment to me. I'm checking the defect. It appears that when you press the power button, the light dims, which seems to suggest that the power button is working properly, and the problem lies elsewhere. Well, let's look into it. We need to figure out why it's become so dim. As usual, we'll start the repair by checking the batteries. This one uses a 7.4V 20th700 lithium-ion battery. Its voltage is 8 volts, higher than the nominal value, meaning the flashlight should work. I have no doubts about the battery's health at this point, so let's move on to checking the cables between the flashlight and the battery pack. I disconnect them and measure the voltage. There's 8 volts. Good. Now we need to disassemble the flashlight and check whether it's getting power from the battery and whether the LED itself is being powered. Since the flashlight is so dim, there might be a break somewhere. I need to check that. I have no idea how to disassemble the housing of this flashlight, so I'm trying different methods, but I'm being careful not to overdo it, lest I damage the device. First, I remove the flashlight from its head mount. This makes it easier to work with and gives me access to the mounting screws. There are 4 of them. They use a small Torx head. They can be removed with a fixed-price screwdriver. What do I do after the screws are removed? That's a big question. The housing doesn't just come apart. Disassembly continues through the lens, or more precisely, its adjustment ring. Turning it clockwise causes it to fly off. The ring secures the lens. Now it can be removed. Next, I unscrew a couple of screws. They secure the LED retainer and the dust cover. Now I can separate the housing. Incidentally, its design uses rubber seals throughout, as the flashlight is marketed as waterproof. Now I can figure out what the problem is, the wiring or something else. I'm checking the voltage on the LED. It's 14.5 volts. Now I need to figure out what kind of LED it is. Once I find that out, I'll be able to conclude whether the LED driver or the LED itself is faulty. I connected it to a lab power source. It starts glowing at 23 volts. I looked for similar LEDs on AliExpress. I found models with a maximum of 12 volts. Most likely, they use the same one here. For example, this model is a 7070, a 20-watt LED, also known as an H15R. According to the dashboard, it measures 7 x 7 millimeters, just like our LED. It can be powered by either 6 or 12 volts, depending on the board layout. Our flashlight uses a 12-volt layout. Otherwise, how could it have 14 volts? It's obviously the driver's open circuit voltage. The LED itself has no identifying marks. It's hard to tell what model it is. I bought one on AliExpress to test it out. This is an H15R. We'll install it in place of the burned out one. I'm desoldering it using this simple method, using a soldering iron. I don't think using a hairdryer is the best idea, as it might melt the LED lens. It's made of a soft material similar to silicone. The new LED is soldered to the board, which also serves as a heat spreader, and the board substrate is made of copper. I heat it up and remove the LED. It doesn't really matter which side you solder it on the board, since the flashlight can be installed in 2 positions. Well, of course, you can't bridge the tracks. I installed the LED across the mounting contact of the heat spreader board. The solder has melted, so you can turn off the soldering iron. And this is the old LED. By the way, the backside is exactly the same as the new one. However, its lens is slightly larger. This is because they're using an XHP70.2, not an XHP70, as I initially thought. You might think there's a big difference, but other than the lens size, there are no other differences between the LEDs. Their currents are identical. I think an XHP70 LED might be used here, but the owner decided to install the exact same model that came with the flashlight, so they ordered an XHP 70.2. I resoldered it and installed it in the flashlight in the same way. Now I'm testing it. The flashlight now turns on. The LED brightness is adjustable. By the way, this isn't actually an LED, but an LED assembly consisting of 4 LEDs. I'm specifically clarifying for the smart Alex in the comments. I think you have a good question. Why did the LED burn out? I can't say for sure, but it might be because of the thermal paste used here to transfer heat from the LED board to the housing. Modern technology is so modern. We used to change thermal paste on laptops and video cards, and now we'll be doing the same on flashlights. As they say, how far progress has come. I dread to imagine what will happen next. Share your fantasies in the comments. Anyway, the flashlight has been restored for a while. During testing, I measured the casing temperature at maximum brightness. With fresh thermal paste, the casing reached 57 degrees Celsius, almost as hot as the graphics card. It's worth noting. Soon, I'll have to install a fan on the flashlight, like Carlson's. During testing, the device worked flawlessly. The LED didn't burn out, but I think its days are numbered if used at maximum brightness, especially in hot weather. Anyway, I'll pray for it to avoid a repeat. Well, that's all I have for today. Thank you for your attention, dear friends, and see you soon.